we want to make a concentrated urine, meaning the hypotonic urine, hypotonic solution, then our posterior pituitary gland can secrete something called antidiuretic hormone, ADH. Let me write you this. Let me go back to this. I forgot to mention. The blood vessels around this area, we call this vasa recta. So recta means straight, vasa like the blood vessel. That means you have, because in this area you have some blood vessels, they are actually vertically like this, they are actually straight like this. So that's why I call that vasa recta. And then antidiuretic hormone ADH, it has a different name, it's called vasopressin. So ADH has a different name called vasopressin. It's the same hormone. It has antidiuretic hormone, meaning that it will help your body to reabsorb more water. So it explains how it works. When we do not have ADH, the collecting duct is impermeable to water, so that the water will just go to the ADH and then it will go to your ureter and then you come out from your body. But when you have ADH, the collecting duct will become permeable to water because the aquaporin, remember aquaporin is the protein channel that transport water through the cell membrane. When ADH is secreted, then the aquaporin will be inserted into the collecting duct, making the collecting duct permeable to the water, and then water can go from your collecting duct, go back to the vasa recta or the peritubular capillaries. And in this case, you will create a more concentrated urine. So the ADH or vasopressin acts on the collecting duct, or the insertion of the aquaporin into the collecting ducts. Diuretics. Diuretics is the opposite of ADH. ADH stands for antidiuretic hormone. Therefore, diuretic is the opposite of ADH. What does diuretic do? Diuretic increase the volume of the urine. Increase the volume of the urine. That means it makes you pee more often. Alcohol is one of the diuretic. Many of us will have this experience. When we drink a lot of alcohol, we go to the restroom all the time. Why? Because alcohol inhibits ADH secretion from our posterior pituitary. And because of that, when we drink a lot of alcohol, we pee a lot. When we pee a lot, it causes our body dehydrate. When our body dehydrate, it causes a hangover. That means the next day you feel headache, extreme headache, dizziness, you feel extremely bad, because of the dehydration. You drink too much alcohol last night. Caffeine is another diuretic. How does it do? It increases the glomerular filtration rate. And it decreases the tubular reabsorption of sodium. When we do not absorb a lot of sodium, we decrease the reabsorption of water. So many of you may have this experience. If we drink too much coffee, we also go to pee a lot. And then we have some other diuretic drug. They will inhibit the active transport of the sodium at the top of the loop of the nephron. That means at the loop of Henle or DCT. So inhibiting the active transport at the loop of Henle, specifically the upper part of the ascending limb, of the loop of Henle, and the distal convoluted tubule, DCT. So pH balance, how does our kidney work for the pH balance. So normally our body fluid is in around 7.4, which should be approximately the same pH as our blood. Alkalosis is when the pH of the body fluid or pH of the blood is greater than 7.4. Acidosis is less than 7.4. There are several mechanisms to help us to maintain the 7.4 pH. These are the three mechanisms. We'll go through it one by one. Acid-base buffer system. It has something to do with our component in the blood, or specifically the ion in the blood. Respiratory center, which is our lung. Yes, our lung also helps to maintain the pH by controlling our breathing rate. It can control the pH value of the blood. And then the kidneys, of course, the kidney can also control the pH of the blood. We'll talk about each one right now. The acid-base buffer system is what happens in the blood is that our blood is a buffer. Buffer basically is a chemical or combination of chemicals that can take up excess hydrogen ion or hydroxide ion, but at the same time, it can prevent large changes in the pH. Buffer is basically a solution that resists the fluctuation of the pH. So what happens when your blood becomes more acidic, meaning that when your blood has more hydrogen ion in the blood, it will combine with the bicarbonate ion, and then they will form carbonic acid. Therefore, in this case, the bicarbonate ion can absorb the excess hydrogen ion. But if your blood becomes more basic, what will happen? If your blood becomes more basic, meaning that your blood will have more hydroxide ion, in this case, the hydroxide ion will combine with the carbonic acid. It's like a neutralization. You will neutralize the carbonic acid so that you will form water and bicarbonate ion. So you will regenerate the bicarbonate ion. And then, how does our lung help to regulate the pH of our blood? So, by increasing the breathing rate, you will help to remove the carbon dioxide. Because carbon dioxide can dissolve into our blood. You can see that carbon dioxide can dissolve in the plasma, which is mostly water, and it will form this carbonic acid. Carbonic acid can dissociate into hydrogen ion. So by removing the carbon dioxide, it can remove the formation, it can prevent the formation of the hydrogen ion, so that the entire reaction will shift to the right. And in this case, you will help to maintain your blood to become too acidic. So in other words, our lung, the respiratory system, control the proportion of bicarbonate ion and carbonic acid. That means it's this part and this part. Oh, no, I'm sorry. Bicarbonate ion and carbonic acid, that is this part here, the reaction of this part here. The kidney. So the third mechanism that to control the pH of our blood is through kidney, which is today's lecture, the main point. Our kidney can remove any lots of acid and bases, but kidney reaction is a lot slower than the previous two mechanisms, namely the buffer system, the bicarbonate ion inside the blood, and also the respiratory center, the breathing, the lung. Kidney can reabsorb bicarbonate ion so that it will reabsorb, meaning that you will move the bicarbonate ion from the filtrate back to the blood. so that our blood will have more bicarbonate ion to maintain the pH. Kidney can secrete excess hydrogen ion. If your blood is too acidic, then excess hydrogen ion will come out from your urine. And ammonia can also be absorbed. Ammonia in your urine can absorb hydrogen ion. It neutralizes the acidity of the hydrogen ion. And phosphate is another buffering ion. Phosphate acts very similar to bicarbonate ion. They can buffer the hydrogen ion in the urine. So all this, when we get rid of excess ammonia, get rid of excess phosphate, they can help to extract the hydrogen ion from your blood so that it will be excreted as the urine. So here you can see that the graphical representation, your kidney tubule. So here from your kidney tubule go into your blood, we call this secretion, or if it occurs in your Bowman capsule, we call it filtration. So the bicarbonate ion can, sorry, I mixed it up. So this part from your kidney tubule to your capillary, we call it reabsorption. So the bicarbonate ion can be reabsorbed back to your blood so that it will increase the buffering capacity of your blood. Or the hydrogen ion can go from your blood back to your kidney tubule. In this case, it depends on the location. If it occurs in the Bowman capsule or glomerulus, we call this filtration. But when it happens in the proximal convoluted tubule or distal convoluted tubule, we call this secretion. Hydrogen ion can be secreted from your capillary into your kidney tubule. And then the ammonia, as we mentioned before, it can absorb this hydrogen ion to become ammonium. This is the neutralization.